We want to find out if this series converges or diverges. So we're going to use a comparison test. With a comparison test, we just want to basically clean up what we have there and see what series is similar enough that we can compare it, and we know something about that series. So with this one, we could do 4 to the n, just remove that addition of 1, and just have 3 to the n. So you kind of have to be just reasonable here with what you eliminate, and just get a feel for it and see what this actually would do. So what would that do? This is something that is a geometric series with a common ratio of 4/3. So if you remember the common ratio here being 4/3, this means that this is going to diverge, because this is not smaller than 1. If this was smaller than 1 for our common ratio, then it would converge. But since it's greater than or equal to 1, then it's going to diverge. So that's just a property of geometric series, and that was something that we're going to use to compare this with that one. So since we know this diverges, if this series is greater than that one, this series is also going to diverge. That's the thing we know. So is this greater? Well, let's reason about it. If we plug in 1, is it going to be greater? We have 3 minus 2, which gives us a smaller denominator than plugging in 1 into here, which would give us a larger denominator. So that means that this is definitely going to be greater. This is going to be greater for 2 reasons. It has a smaller denominator, and if we plug in 1 into here, it's going to give us a greater numerator with a greater exponent. And so it's going to eventually, with time, become even more noticeably larger than that series over there. So since this is larger than that series, and that series diverges by using this geometric series property, then this also diverges.